Welcome back. Today we're going to be looking at average rate of change. Should be a pretty short day today, not too complicated, but it's important that you understand this as we move forward. So we'll get started with our creed and then move on. Today is a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it's worth it. All right, let's go. Let's break it into average rate of change. This is the most common thing you did probably back in 9th grade, maybe 10th grade, maybe 8th grade if you were working on it. And it's that S word that you use in every class you've ever done, every math class ever. You know, you've talked about this word called slope. The average rate of change is just breaking us down into slope. Now, it's the average slope. It's the slope that happens when given 2 points. And you'll see those 2 points in just a second. So we're going to define it in a lot of different ways. We talked about it in class. But basically, you can redefine it in change in y over change in x. Some people call it the variable m. Some people call it average slope. Some people remember the y2 minus y1 over x2 minus x1. I'm running out of room. Hop over here. If you ever took a physics class, you might have learned it as a y final minus y initial divided by x final minus x initial. I'm probably missing one or two, but there's so many different ways we can talk about this average rate of change. So let's break it down and get into it real fast. You can read through all the definitions. You can look at all the graphics and the images. But when it comes down to it, it comes down to just applying this formula. You can apply it in steps, or you can apply it all at once. In either way, you'll get the same average rate of change, so you'll see that in a second. So the formula is f of b minus f of a divided by b minus a. So the first thing we need to define is our a and our b. Usually left to right, usually working with a smaller number growing into a bigger number on the x-axis. That doesn't mean you know what's going on the y-axis, just the x-axis, usually working left to right. So what I'm going to do is I'm going to take those two numbers and I'm going to plug them in, right? I'm going to plug them straight in for this. I'll do it in red so you can see. So we've got f of minus f of over, and here we go. We're going to plug in the red. 3 minus f of 1 all over 3 minus 1. Just like that. And then when we work it all out, this is where we take our function and we plug it in. So we're taking that 3 and we're plugging it into our function. And this is where I said if you want to do it in 4 distinct chunks, you can. If you want to break it down and do f of 3, solve that problem, get a number. Then f of 1, solve that problem, get a number, you can. But I'm going to show you the way that I do it by just plugging it all straight in. So we're plugging it in. So we've got 3 minus 1 squared. That's where I got two people today asked me that question. Where did you get that from? Right there in that blue. All I'm doing is using that function to rewrite these f's. So there's no more f of 3. It's now that function with 3 plugged in minus that function with 1 plugged in all over. We're going to go ahead and simplify that to 2. All right, so if we do it again, we should get 2 squared minus 0 squared. Whoa. Something's looking wonky. No? 3. Oh, that was a terrible plug-in of that function. If you look up at that blue function right there, it's x minus 3, not x minus 1. I don't know where I got that 1 from. So now if we break it down, this looks a lot better. Now we've got 0 squared minus a negative 2 squared over 2, which is 0 minus 4 over 2, which is negative 4 over 2, which works out to be negative 2 is your average rate of change. That's it. That's all this whole page is doing, this average rate of change. We're going to work a couple more, though, just so you can see some practice. But that's pretty much the... if we want to look at it on this graph pictorially, that average rate of change, that 2, draw this line right here, is the slope of this blue line. So it's the slope of the line called the secant line, but it's the slope of the line, the invisible line made by connecting 2 dots on a graph. And that's all it is. So we're going to skip down a little bit. We're going to look at using a table. No different. Using a table is exactly the same as using a graph. We're going to go f of b minus f of a all over b minus a. We're going to define an a and a b. Well, the graph probably does it for us. A turns into b. 8 turns into 9. So there's our 8 a.m. and there's our 9 a.m. And all we're going to do is take those numbers and plug them straight in. So 40 minus 38 over 9 minus 8 equals 2 over 1. There's our average rate of change. If we're going to label it with some good numbers, what's happening is it's 2 degrees Fahrenheit per hour. That's the average rate of change. It is changing 2 degrees every hour in that instance from 8 to 9. Not too crazy? All right, let's look at one more kind of fun one. I think it's this. Yep, this is the last one. This is a pretty fun one. So what I'm going to do is I'm going to work these out really fast, and then we're going to look at something cool that happens in between them. So if we've got f of b minus f of a over b minus a, what we've got going on is 3 times 1 minus 5, parentheses, minus 3 times 0 minus 5, all over 1 minus 0. And if we work that all out, we'll probably get something like negative 2 minus a negative 5 over 1, which is going to give us 3 over 1, which is just going to give us an average rate of change of 3. Okay, let's work it out again with different numbers completely and see what happens. So this time we're going to end up with 3 times 7 minus 5, put parentheses around it, minus 3 times 3 minus 5. I'll go ahead and label A and B just so you know, but they're always going to be the same. We're always going A to B. Okay, all over 7 minus 3, which is probably going to get us something like 21 minus 5. Math is hard. 16 minus 9 minus 5 is 4. All over 4 ends up being 12 over 4, ends up being 3. Holy moly. Look at that. We've got the same rate of change for these two equations. One more try. This one I'll go a little slower because it's important. This is probably one of, if I had to pick a most important problem on this whole page, this one's it. So I'll go a little slower and do some better coloring. F of b minus f of a all over b minus a. And remember, we're taking this for a and we're turning it into b. So it's a little trickier because we don't have any numbers here, but it's really important that we see what happens. So the function of b. B is all this stuff in red right here. So what was the normal function? I've already forgotten it. 3x minus 5. So 3. And instead of x, what am I plugging in? I'm plugging in that b, right? So I'm going to do this one in blue, and I'll do a in green. That way you can kind of see. Okay. So we've got 3 times a plus h minus 5. There's my f of b. Minus 3 times, and this time I'm going to do it in green, I said, times a minus 5. There is my f of a. So I could label that real quick. This is f of b, and this is f of a, right? So we got f of b minus f of a, and then we need to divide all over b minus a. So here we've got b is a plus h, so I'll label that b, minus, and here in green we've got, oh, just a, which the a stands for a, which is kind of funny. All right, so here we go. Now if we work it all out, we're going to do distribution first, because don't call me after midnight. 3a, so here's that distribution that I'm talking about, and then I'll probably have to distribute this negative as well. I can do those all in the same step. 3a plus 3h minus 5 minus 3a plus 5. All over. We've got a plus h minus a. I'll leave that for now, and we'll see that those cancel. Those a's are going to cancel. Different color. Those 3 a's are going to cancel. They're not canceling also. Those two are both turning into 0, because 3a minus 3a is 0. A minus a is 0. Green, we've got these 5's turning into 0, and we're left with 3h over h. The reason I switched the phrasing from cancel to turn it into 0 is because we're going to do what's usually called canceling again, but this time it's turning it into 1. So it's important to see the difference between those two. So now what we're doing is we're turning h over h into 1 over 1, which leaves us just with 3. And if we look at this for the past 3 problems, and that's it for the whole video, what we've got is we've got 3, 3, 3. We've got the exact same slope, or average rate of change, for the problem. And we're going to go and look at the first original equation and say why. Why do we have the exact same slope? Well, if we look at this original equation, and we think back in Algebra 1 days, you remember that y equals mx plus b? Well, those all stood for something, right? Y was your dependent variable. Equals is your equality. M is your, and this is where it gets cool, your slope, right? Well, holy moly, there's a 3 right there. We're saying straight up M is 3. Slope is 3 in this problem. Does that make sense with our answers? No matter what numbers we picked, 3, check, 3, check, 3, check. Even if we didn't use numbers and we used letters, no matter what you did, you're always going to end up with 3 as your slope, because that's a line, and that's a linear equation. So, linear functions and rate of change, slope's always the same. Tables, plug and chug. Working with a graph, we can identify what the slope looks like in the secant line, and that's pretty much it for the day. Thanks for watching. Make sure you're working on your homework. Make sure you're working on everything for class. Make sure you're emailing me if you have questions or if you need help with certain types of problems. I'm happy to work them, happy to help. Have a good day. Thank you.